Let me check on YouTube first. Yes, we are online. I'm gonna start in Turkish first, and then we'll continue in English. İyi akşamlar herkese, iyi akşamlar dostlar. Herkes hoş geldi. Nasılsınız? İyi misiniz? Afiyette misiniz? Bu akşam çok önemli bir konuğumuz var. Steven Beelen ile birlikteyiz ve yayınımız İngilizce olacak. Bu noktadan sonra ben İngilizce devam ediyor olacağım. Yayın sonunda da sorularınızı Türkçe'de sorabilirsiniz. Ben elimden geldiğince İngilizce'ye çevirmeye çalışacağım. Alright, we can switch to English. I would like to say very welcome to our community, basically. You know, we both, FolksDev and Turkish Java community, mostly work together, and we are really happy to see you in our broadcast, basically. And today I have also my dear friend Evren, who is co-founder of the Turkish community, and Steven Van Beelen from Axon IQ. He is working as a framework lead developer, and we are super lucky to have him tonight. So I would like to give microphone first, Evren. Good evening, Evren. Welcome.
Good evening, Çağrı. Thank you again for this opportunity, for this joint session with FolksDev and Turkish Java community. It's great to also host Steven for his great topics. Really, we have really great topics here. As you mentioned, Steven is working as a lead developer at Axon. We are going to go over DDD concepts, command query, responsibility segregation principle, event sourcing. Really, we have great topics here. And at the end, Steven has also a live coding session. So thanks again, and thanks, Steven, for being with us tonight. Thank you. And the mic is yours, Steven. The show is yours.
Yeah,
yes,
the show is yours.
All right. Thank you for the kind words. I'm very happy to be at this opportunity to talk a little bit about the stuff that I work with. So I had a decent, lovely introduction, so thanks for that. Regardless, I'd like to share a little bit about myself. I do see that my camera is extremely light. My apologies. I'm doing a lot of work in my house to renovate things, and the lighting at my desk is just not as it's supposed to be. So let me select at least the right screen. If this is not visible, please tell me so. Yeah, a little bit about me. So I'm Steven. Just call me Steven. That's fine. My surname tends to be a bit difficult. I work for Axonic or Axon IQ, and for Axonic, I'm the lead developer for Axon Framework. An Axon Framework is an open source Java-based framework giving you building blocks to work with CQRS and to work with TDD and event sourcing. I've been working with this stuff for the last 8 years or so, I think. And in that flow, I joined Axonic from the start, and I became the lead developer, meaning I manage the construction of new features and help people out with consultancy formats and training. But I also very much like to do presentations like this. So if you have any questions, by the way, I understand that this is normally all done in Turkish. As you hear, my Turkish isn't very good, so I'm doing this in English. I will try to keep the tempo a bit down to simplify it, but still, if there are any questions, feel free to type them in your own language. They will be translated for me once that point is reached that we can answer those questions. Now, with that said, I think it's time we move over to the slide deck. We first go through the slide deck with some presentation to get those concepts in the same place, and then we're going to look at a demo. Somewhere in between those two, there will be a moment to ask questions as well. So you can ask stuff based on what I'm now presenting. And then afterwards, you can ask stuff based on the actual code. So with that said, let's look at event sourcing with Axon Framework. But let's assume this works. Yes, it works. But why? Why would you want to do event sourcing? Why would you want to use Axon Framework? Why is that going to help you build your applications, it's good to get a common understanding, right? So for that idea, I have a journey in mind I want to take you on. So let's assume you and some friends of yours or your current job, you have a brilliant plan to build some software, and it's going to be the best thing out there. It's going to be the best thing because you're going to have millions of users, or you're going to reach hundreds and hundreds of tenants that want to use your software. So because of that size, you feel, okay, I need to have things like these types of databases. I need to set up all this kinds of infrastructure. I'm definitely going to do microservices, and I'm going to all do that. We need to go that route. So you have a business idea to provide value, but you're first going for the actual solution to the fulfilled thing that's going to provide you that value. So you start about thinking about the infrastructure, how you're going to communicate with these components, what kind of databases they're going to use. You're going to set up those teams, and by doing that, you're more focusing on non-functional requirements. So requirements that are necessary to scale out, to communicate between those things, not necessarily the requirements that are there to solve the problem your business has or that your application is going to provide. So this journey is doable. I know that people do it, but it is a hazardous road. It is quite difficult to traverse that death valley, so to say, to actually get a full-fledged working microservices environment that does everything you want to do in a timely fashion. The chances are even high, because you're focusing on those other concepts, that you end up with more a type of distributed ball of mud with these little beetles, which you'd call the architects, on top of the balls of mud. So instead of taking this journey, I recommend we take another one. That we start with making just a simple, well-structured monolith, but well-structured at that. I recently heard the term modulith, so modular monolith, and in all honesty, I kind of like it. I think that makes sense, because we still want to have well-structured modules inside our monolith. Because if we do that, if we compartmentalize the logic in the right portions and just run it as one thing, then as the need arises, we can start thinking of those non-functional requirements, like that we need to extract the blue component into its own microservices, or that the purple components, which are tasked with dealing with all the REST operations, for example, we need to scale that out for fault tolerance reasons. Could we even think of moving that into the cloud eventually? So we take a different journey towards a microservices architecture. And this is where I think that event sourcing is going to help you. Let me explain you why. But before we get there, we start here. We start up top. We start with making a well-structured monolith, a modulith. So we start with a blank slate. We go into a design session with you, your friends, your current company, your team members, and you make an empty sheet and you think about what it all needs to do. What kind of services do you need? What kind of components are going to communicate with one another? How I'm going to design my APIs. So in that flow, you come up with a lot of boxes that connect with one another because they need to speak with one another directly. And this will work. You'll have a model that'll work. But this is all very much tied together. So we need to find a way to cut some of those lines to get a bit more freedom to our components, to make modules, actual separate modules inside of it. So we start cutting some of those lines, and we need to give purpose to these components, to these groups, give them an actual intent, a group they belong to. So we need to, I like to make this colorful. We actually give them color. So this is fair, but these modules still reside within one application landscape. So even though I very practically cut those lines, there is still communication going between these components. Well, there is a very specific networking topic that is going to help us to make one application that can talk between all the components inside, but these components themselves don't have a clue with whom they're talking. And that concept is called location transparency. Location transparency comes from the networking environment. So you can reflect this, what you have with the router in your house. And it is stating that a component should neither be aware of nor make any assumptions about the location of the components it interacts with. So this is a physical location, but this is also very specifically like an import statement, the actual code you're invoking or the APIs you're using directly. You don't know that stuff. You don't know the local host or port combination either. You don't want to know that. You want those components to be unaware of one another. So I'm going to even strengthen that they don't even know with which components they communicate. Because if we do this, then they are still communicating. Location transparency is helping with this, but they don't know where they are. So they can be within a single JVM, or they can be within any number of JVMs, with any number of instances as well. So this gives us that freedom to move from one monolith to a microservices architecture once we really need it. So giving us great flexibility in there. Okay. This is nice, similarly as what I previously had. But how do you do this? How do you come up with a design that gives you this location transparency? Well, we're getting there. Let's move over to a following approach of the application landscape. Let's assume that down below we have a box that is our user interface or some API that we use to communicate with two rough separations of our application. So one side is dealing with operations. So it needs to perform this or perform that. It's ingesting those operations and dealing with that, validating the business and performing some tasks. The other component is there to provide information. So it receives a request and it returns that information that is requested from it. So we have these dedicated clouds. This is fine. But the operations end is, well, in essence, making decisions. It is getting a task and deciding whether it can perform that operation or not. So that is where our state changes happen, on the operations end. So this is where the changes occur. Those changes, one way or another, need to get into our information cloud as well. So we need to have a form of synchronization between these two as well. So what I'm showing here is, in all honesty, command query responsibility separation, or CQRS for short. And what we're doing with operation, information, and synchronization is I'm talking about commands, queries, and events. So we're going to use commands and queries as events to drive ourselves, to give ourselves that location transparency. Because these commands, queries, and events are not just a means of an API. There are specific types of messages. And by using them as specific types of messages, the distance those messages travel can be any length you like. You just need a component in the middle that is dealing with the logic of getting it from one point to another. And that can be within a single JVM or in a distributed environment with using several microservices. So these messages are going to be of great help and further drive the design of our application. Let's talk about these and why we want different messages actually, and not just a single one. So you might have heard about events. Event-driven architecture is a very reasonable concept we see occurring a lot. But what an event really is a notification that something relevant has happened. And that has happened, the past tense, that is very important in here. It means that it is something that doesn't necessarily happen in that moment. It might be something that happened 5 seconds ago, or 5 minutes ago, or 5 years ago. And because of that idea of the flow of a message, it's a one-way street. You cannot directly reply to the event. This means that if you're a consumer of events and you cannot deal with that format, then that is your problem. Or if you're not happy with what the event is telling you, and you want to return saying, okay, you need to do this differently, well, you can't directly do that over that same channel. That would mean you need to do a different message. So there is no means of a response, and it is, well, past tense. Furthermore, as it is something of history, it's shared with everybody. Everybody is allowed within your application sphere to read all types of events. There's no single handler of this. Commands and queries are different in that perspective. A command is a request to perform an action, the expression of intent to perform an action. So the desire to do something. This makes it not past tense, but current tense, like do this or do that. Furthermore, it is targeted towards something or some model instance that is in charge of deciding whether that operation can be performed at that moment in time. And because there is a single service or instance capable of doing so, commands are routed to a single source. So because of that routing to a single source, especially in a distributed environment, we need to know how to route it to one instance consistently. And we also want to have some form of a response. We want to know whether the decision was accepted or not. So an okay or a not okay. So this is bidirectional, but directed to one source. The queries are, again, a different type of message because they also have a different type of an intent. You can do a request of information where you will most definitely get a more fulfilled response object. So the responses are definitely in there. It's again bidirectional. But I could ask somebody something specifically, some component in a load balanced environment or in a scaled up environment where you have several instances, then you have several instances capable of answering that question. So you want to do load balancing to efficiently share it over the nodes. Furthermore, you can also think about queries where you're not sending a query to a single component capable of answering that query with a response, but also to a group of components. The way I would typically like to explain this is that let's assume we want to go for dinner afterwards. If we would actually be sitting in a physical room, then I would ask, so where are we going? And I'm not asking it to one person. I'm asking the entire group. So that's not different from what you should be able to do in code. If you have a request that rightfully more components can answer, why not gather several responses? By having these separate types of messages, we can very much clarify the intent of what you want to do. We make our API very clear in these perspectives, and by making them actual messages, we get that location transparency goodness, giving us the flexibility to go from a module to separate microservices. Okay, let's move on to my following slide, because we filled in the commands and events and the queries in our CQRS diagram. And in all honesty, this is what you'd have at the core of doing CQRS, just the separation of commands and queries and the means to synchronize, for which we've now chosen events. We're going to add a bit more to this though, because we very deliberately left out the internals of these clouds. They are dealing, okay, this cloud is dealing with commands and this cloud is dealing with queries. And apparently this cloud dispatches events that are then used by the query end to update itself. But what's in that? What do we actually create in here? Now, we create specific types of models in here, specific types, we're reflecting the model types we need from a CQRS perspective. But moreover, this is actually where we're going to use domain-driven design. So domain-driven design, in short, DDD, states that at the core of your application, you have a so-called domain model. From the image down below, you might reflect this as the original domain model we had. So DDD helps us to derive an application with the entities that connect with one another and the components that chat with one another. They don't necessarily dictate the messaging. So this is not where the lines are cut. If we enhance this further, if we look at the building blocks, we have things like entities in here, value objects, repositories. The notion of an event comes back. We have the concept of a bounded context, which gives us that color to separate our components. And I want to mainly focus on one of these because it's going to help us to better understand the live coding session. And that's the bit about the aggregate. So an aggregate, please, this is a rather rough explanation, but I can't sadly make it much easier. So an aggregate, if you really break it down into smaller explanation components, there are like 3 rules to it. An aggregate is a group of associated objects that is considered as one unit in regard to data changes. So if we take a step back, that means that an aggregate is not just a single thing, but is a group of things combined. And when it changes state, it's not just one of those objects inside that changes, but the entire thing changes. So there's some form of atomicity, at least from the outside world, when it comes to an aggregate. Okay, fair. Let's look at the second rule. External references are restricted to one member of the aggregate, designated as the aggregate root. Okay, all right. So within this group of associated objects, there is one object or member that is the aggregate root. And that is how you reference the entire aggregate. So there is one component in charge of being the starting point when it comes to routing. Okay, that's fair. Okay, let's look at the last step. A set of consistency rules applies within the aggregate's boundaries. All right, so things are tightly consistent with one another within that group of associated objects. Okay, a lot of conceptual stuff. In all honesty, it might take some time before this really lands. That is fine. Let me give you a real life example of what I feel an aggregate could be. So if we look at what a car is, or a vehicle in general, a car, let's see if we can apply these three rules. So group of associated objects. Well, no, I know for certain that a car consists out of several things. There is an engine, there are doors, there are wheels, there's a steering wheel. And it's those group of objects, of entities and value objects that combined form our, group of associated objects. All right. Rule 2, the external references. So when it comes to a car, well, yes, that has one member that is the external reference. This is typically the license plate. This is how you would refer to your car. At least that's what you need to do when it comes to, the government, right? Or when you're paying your taxes around your vehicle, you need to provide the license plate. In different contexts, this might be something different though. If I want to lend out my car to a friend, I would say, well, it's the black Toyota Auris outside. They don't need to know the license plate. They can just know, yeah, it's the one over there. And that would be sufficient. So that would be my means of talking this as the external reference. So, okay, this also works. Now let's look at the consistency rules bit. If I'd make a change inside the car, like I turn the steering wheel, well, I'd most definitely expect my wheels to turn. Granted that the car isn't broken, of course. But yeah, I think that applies. So think about a car when you're thinking about an aggregate, because it consists of several things. There's one reference, and there are certain rules that you expect the car to comply to. All right. With this in hand, we've just looked at domain-driven design, but we're going to combine this with CQRS, with command query responsibility separation. And that dictates we don't have one domain model, but we have two models. One model we call the command model, and another model we call the query model. The command model is focused on executing tasks because it gets those expressions of intent, those commands. Sounds fair. And all it really needs as state, the command model, is the data required for task execution, decision making. This is also fair because it gets those expressions of intent, those commands, and it needs to decide whether that operation can be performed. Well, if we look back at that car example, when I'm turning the steering wheel, I think state like the color of the car is not important. I don't need that in the command model of a car. But if I'm looking at a query model of a car, and you want to have information about what the car looks like, what features are inside, well, yes, I want that state. So when it comes to a query model, it's really focused on delivering that information as you might need it in different formats. This allows us to store the data as it's really going to be used, so we can denormalize our data in essence. The way how we reflect that in these models is that the command model is really a group of associated things because it has to be for decision making. So this is why these boxes are interconnected. But when it comes to query models, well, if you use a relational database to store your query model or your projection in, then sure, you can use joins, and then you essentially have two tables connected to one another. But the beauty of separating these two models is that our query model can be focused for one specific task only, if that's an optimization you need. So we can break that apart. We can break those models apart. Long-winded story. So Let's fill in the idea of those two models in our diagram. So we actually have CQRS and DDD right now, where we're using command models on the left to handle the commands, to validate its state. Is it okay to perform this task? And if it's okay to perform that task, you'll publish an event. That event is then used to change state on both ends, on the command model and on the query model's end. And this is actually a very good bridge. So these events are used for synchronization, definitely for the query model's end, but they're also used for themselves, right? Or are we just changing the state? So let's have a look in a bit more detail. I think I saw some requests flying through. Okay, I'm gonna go through those questions at the end of the slide deck. Please bear with me. I hope that's okay. Just gonna look at the synchronization of it all. So I have a different diagram for that, of course. So let's break it up a bit. Let's assume that both our command side and both our query side have a database they're storing their models in. So this is our command model database. This is our projection or query model database. The command side gets a command. The model is loaded from the database, and it is validated, and well, there's some form of an okay, so an event is published. The event flows to this event bucket somewhere in the middle. Right now, we don't really care what kind of infrastructure it is. There's just a bucket of events. So this is all the command side would do. We just publish it on the events bus or group. The query side on its own would stream those events. So would read them on their own accord, really making it an asynchronous process from making the decisions on the one end. So this format of message flowing, that's what you'd call event streaming. So the command side isn't directly streaming it to the query side. No, that's separated. The query side is streaming from some bucket, some bus it has, and gathering all those events. Okay, so this is what you'd call event streaming. Let's change our diagram a little bit. So what if we remove these databases? We don't have anything on the command side, and on the query side, well, we're free to edit or remove it. We don't necessarily need it. So, okay, how can we do this? Well, first and foremost, we don't necessarily have to remove it. We can still read, we can still keep it. But on the command side, we need to have a way to load that model, right? We need to still be able to handle subsequent commands. This is where the events come in. We can use those events in the middle, not just to synchronize the query side, but also to update or recreate the command side. This is what you'd call event sourcing. And what is of utmost importance when you're doing this is that these events are maintained, that you have an event store. You cannot use an ephemeral storage mechanism like regular message queues, or, well, unless you set up Kafka to handle everything till the end of time, which it isn't intended for, Kafka wouldn't be this either. So what we're doing is essentially moving the responsibility of those two databases into having a single one, our event store, which, well, it doesn't keep the fulfilled model. It just keeps the separate changes. Let's move through this a little bit further. So what event sourcing really is a type of event-driven architecture. It's not event streaming. Event sourcing is a more specific format intended as a storage mechanism for the command models, for the command side. And what we do instead of storing the fulfilled model is that we store the separate changes. Which are those events? Those generated events can be used to that end. So when you're sourcing a command model, you would generate an empty instance, you would retrieve those events from the event store, and you would recreate it on the fly every time again. And this requires an event store. In even a bit further detail, if we would be using a state stored approach of an order, on the left here we'd have some form of a very simple JSON format. I'm not even sure if it's correct, besides the point, in all honesty. We have an order, there's an identifier of 1, 2, 3, there's an item of a deluxe chair, and we have a status, return shipment received. Fair. This is what you would be accustomed to. This is what you would still have on your query side. But what we do with event sourcing is that we keep what has happened, because with those separate changes, we can recreate this format, but we can also recreate different formats. We can make a model that just shows the status transitions of being created, of confirmed, of shipped, of canceled. Or have a different model of analytics stating, okay, some users apparently first want to buy 2 chairs and then remove one of them. We need to figure out why they have been doing this. It gives us additional insights in what is happening in our system, essentially a far fine-grained audit log than you would ever have. And we can make these models as we see fit. So with that said, we're going to combine CQRS, D2D, and event sourcing in one diagram. So with this in place, we have a rough distinction of 2 sides of our application with command models and query models. We have an idea of how we're going to design our APIs so that we get that network or location transparency through commands, queries, and events. And furthermore, we're going to store those events in an event store so that we can both support event streaming and event sourcing to their best of concerns. But how? This is nice and all, but this is purely just theory at this stage. And well, even though there's a lot already said about this, and it's kind of interesting nowadays, I think, this environment, if you want to build all this from scratch, that idea of that you first start making one well-structured monolith to focus on your business functionality goes out of the door again, because you can't focus on your business functionality if you need to create all the logic for an event store, for messaging, for domain-driven design with its aggregates of repositories and entities. So you can build that, of course. That's interesting work. But is that the best thing to do? So we need to make the glue within our monolith. We need to fill in the blanks to make it all interconnect. You might have guessed it. This is where I think that Axon framework is a good fit. In all honesty, there are different frameworks out there. I do believe that we are currently the oldest and longest running with quite a big user base at this stage. And that is what I'm going to use. So I'm going to use or provide you a demo where I'm going to show how Axon framework can help us build an application using those ideas of CQRS, D2D, event sourcing, so that we get a well-structured monolith. This brings me to the point of my demo, actually. A little bit about the demo. The domain I'm going to construct is a game rental domain. So it's an application where you can register, rent, and return, in essence, video games. And you can find them likely. You can search the application. For this, I'm going to use Axon Framework, as you see. I'm going to combine that with Spring, because that simplifies my configuration life greatly. And I need to have some form of an event store. And for that, I'm using another tool we have. Again, this is not, you're not limited to using this tool. There's freedom. But I'm going to use it because it simplifies my application life. And I think it will simplify yours too. All right. So halfway in, or half an hour in, I think that's good. Let me see if some of those questions are something I'd say. Ooh, there's a lot of questions. That's good. Helpful. Let me read this a bit, or my apologies. I say a lot of hello. Hello, everybody. Happy to be here. I hope you have been enjoying it so far. Okay, that's one question. That's two, I guess. But they're definitely not in my language, as I pointed out. Okay, there's one that I am able to read from Furkan. I hope I'm pronouncing your name correct. If not, my apologies. In the CQRS approach, the data between the two databases need to be synchronized. Does Axon bring convenience in this regard? The data between the two. Yeah, in essence, yes, it does that. The framework helps you to do that synchronization, to get those events published from one end into that event store, and to be able to stream them from that event store into your environment. A lot of that is actually very much tucked away, that you don't have to do, well, in very simple scenarios, not to have to do anything. So the demo I'm going to do will mitigate a lot of the specifics under the hood from this. If we want to dive deeper into that, we can, of course, but yeah, it helps you with that. Okay. Oh, yeah, Mohammed, thank you. Happy that this helps. Always good to hear. So it was very instructive to explain the CQRS pattern with examples. Very pleased to hear that, because, well, I've been doing this from some time, but it's always good to hear that that the examples or the samples resonate. That's thanks for that. Okay. See you, FolksDev. I will raise your questions before the live coding session. Guys, you can share. Yeah, okay, gotcha. Okay. Fionk says, we don't like Kafka-based event-driven design after Axon, to be honest. Is that okay? Is it necessary to completely migrate? I'm not sure whether the first one from Fionk is just a statement that this is what you're feeling. We don't like Kafka-based event-driven architecture after Axon. But if that's your point, that you don't necessarily like to do event-driven applications with Kafka anymore after you've tried Axon, I can gather that. You know, Kafka is very strong, right? It's very fast and very efficient in event streaming, and it's on a level that we'll never reach. I need to be honest with that. But it lacks a lot of the integrated tooling that we have, and also on a broader perspective. Kafka is really intended for event streaming. And we're not just doing event streaming. We're also doing command routing and query routing. And it's an event store, and it provides all those building blocks for DDD. So it does more. It gives you more ingrained solution for this. Even though Kafka, well, has information out there that you can do all those designs, and surely you can. But it's, again, mitigating away from providing business value for you to solve your problem. And instead, you need to make all those components, which, well, is doable. But yeah, I can imagine that you'd prefer to use Axon. In my honest opinion, I do too. Then again, I am a bit biased, of course. So, all right, let's go to the following one. Is it necessary to completely migrate a project running on Spring Boot to Axon, or can they work together in harmony? Now, well, Furkan, that's easy. Yes, they can work in harmony with one another. So the framework is built up such with separate modules inside that the basis doesn't necessarily require you to use Spring, but it works very well with Spring because we have a dedicated module to provide stereotypes for Spring. We also have a Spring Boot auto-configure module so that you can, well, just use that. I will actually be using that in the demo so that you don't have to configure any of Axon's components by hand. It'll just do all the regular defaults. So if you already have a Spring Boot application, you're going to use Axon. Yeah, it's a simple transition, I'd say. Yeah. Okay. Leafman agrees. Fionk. Yeah. All right. Mohammed, indeed. What does Axon do differently from Kafka for event sourcing? Yeah, Mohammed. What we do differently is we, by default, what the framework by default does. Will I do this right now? I'll leave this to the live demo because then I can make it a bit clearer if that's okay. Yes, we do things differently when it comes to separating the event streams, but it's a bit clearer to show if I actually have the code at hand. So please bear with me. And if you feel that after the demo and such, you don't have the answer you're looking for, please interrupt and we'll cover it further. Okay. Okay, I see. Yeah, that one. Furkan, how is the security of your data provided in cases where Axon services are down? Yeah, if they're down. So I find this a curious one. How do I explain this? So if you're using Axon framework, let's move back a couple of diagrams. All right. So not this one. This one. So from the majority perspective, your entry point is through here for your UI or your API. If this is down, this component, then, well, you don't have any means to interact with the command model and the query model. So you can't, there is not necessarily security hazard in this case. If your UI or API is down, or if one of those command model or query model instances is down, you similarly have no means of connection to get in there. What we do provide and what we do recommend as well is, so in this application sphere, this could be one single monolith. So in that perspective, you want to get your security on the edge. You want to make certain that everything that comes in has potentially roles assigned to them. So they have logged in, they have a certain set of rules that applies to them. So they're allowed to perform these and these commands or these and these queries. If you're in a single monolith, that's easy. You'd have that one security context and that's validatable at every point. But what we're recommending or allowing you to do with this is that you can break up your monolith into separate entities. So you want to attach that security information to all your messages. So you'd want to have some form of a token present on your command messages and on your query messages, so that when you're actually dispatching a command from a UI and it is handled in your command model, that upon handling it, upon accessing, entering that application, you'd validate that logic. So you'd be protective of things on the fly. I'm very deliberately leaving here the command or the events out. I'm talking about commands and queries, because this is how you would interact with your system. You either want to do something or you want to have some information. That's it. However, a hacker or somebody that has maleficent intent with your application might just want to have your events. It will just read them. And as your events are a very clear audit log explaining everything, that is extremely valuable information, especially when it comes to personally identifiable information. So you might have heard nowadays about the GDPR Act we have in Europe, that you're not, that you're as a user capable of stating, I want my data to be removed. It needs to be encrypted. All that ruling is now in place. This means that you want to encrypt your events as well, because these are stored indefinitely. So there is a means to, when you're actually publishing your events, when they're moving to the store, that you can mark certain fields in the event as personally identifiable information, and that the framework will automatically encrypt those and decrypt those if it's needed. I hope that answers the question, Furkan. Similarly, if not, we go through it. Let's move to the following. Okay, Furkan is getting good vibes. Happy for that. Nice. Let's move to Mohammed again. Basically, what I'm wondering is, what are the main differences between Kafka and Axon? What exactly is Axon's innovation compared to Kafka? I assume the thanks is a thanks for this. Okay, Furkan has answered. His questions have all been answered. Yeah. Okay, so what I think the main benefit here is, Mohammed, is that the framework focuses on a different set of architectural paradigms. So we focus on CQRS, DDD, and event sourcing with a messaging paradigm in the core. So for commands, events, and queries. And Kafka really is a very, very efficient piece of infrastructure, allowing you intercommunication with virtually any language. Axon isn't there yet. Axon framework is really for the JVM space right now. What I will be doing with Axonic Cloud that I'll be using in my demo is adding our version of a messaging bus as well. We got our own. We call this Axon Server. This is a tool you would run that does the communication between, for example, framework applications, but it's not limited to framework applications. What we do there is almost in a similar vein as where Kafka has been going, is allowing you a means to define an API that is outside of any language specification, so that you could also go from a Python application through Axon Server and then to an Axon Framework app, or a C# or a Rust application. But that is just not a space we're in right now as Axonic. So Kafka gives you a very good interoperability between any type of application you might have, just because it is there, although it focuses on being an event streaming solution. And we are a solution that allows you event streaming, event sourcing, domain-driven design, and the help with CQRS to have commands and queries as well. I hope that explains the question. All right. Good stuff. I think we reached the end. Yeah, I think we have. So again, feel free to ask more questions. For the time being, I'll move to IntelliJ, because This is my favorite IDE. I use this a lot. I'm very happy with this, so I hope this is visible. It seems to be visible as well if I look at my screen down. If you do think this is too dark, please tell me so. I'll put it in light mode. I'm not very picky on this. I just personally prefer to be pleasant to my eyes. The project I'm going to use is the game rental project. And for the keen of eye, you might have already seen the GitHub handle down below. If you want to see this project, it's here in my personal environment or my personal repo, the SMCVB. This stands for my full name, just in short. And the demo I'm now going to use has several steps in it. The README is intentionally pretty detailed, so you can move over the steps I'm going to show yourself if you like. And I think that might be beneficial if you start an application. However, I'm going to start at step 1. And as you can see, step 1 has provided me a so-called core API package. This contains the commands, events, queries, and the query responses. So it is the basis. It is the API of my game rental application, giving us a backbone to start working on. To get each of us on the same page, let's have a look at the POM we have. So I'm using Maven in this case. You can switch this for Gradle, of course, if you like. This is a Java 11 project. Could have migrated to JDK 17 or more recent stuff as well. I just haven't done that yet. My apologies. And the Axon framework version I'm using is 4.6.1. I'm using the bill of materials though. So if I go down to dependency management, you're seeing I'm using an Axon bill of materials. If you are going to use Axon framework, I recommend you use the bill of materials as well, because we not only have Axon framework as a repository, we also have additional extensions to provide you a gateway towards Kafka, for example, or AIMQP, or Spring Cloud things, or Mongo, or whatever we might think of in the future. All the things we see as valuable, but not necessarily core to the framework, go to a separate repository, which we call an extension. And the bill of materials ensures you that the versions of these two or several things you're using are in line. So the way I'm doing that actually is that I also have one of those extensions. I'm going to use Reactor in this project. And Reactor is currently an extension of ours. It might move into the framework eventually, but right now it is an extension. So I want to make certain those versions work for one another. So I got a number of Spring Boot starters. The Axon Spring Boot starter, as I pointed out, so giving me all the benefits of easy configuration. I'm going to use data JPA, so we are going to store some stuff. I'm going to do that in an in-memory H2 database, though, because I don't really need anything other than this to store my query models in. I'm going to use Webflux, so I'm going to make a plain REST controller as well. I got DevTools, I got some test dependencies, and that's really all there is to it. So if we move to the intestines of our code, the main project, where you can see that this is a plain Spring Boot application. And that's all there is to it. Just a simple Spring Boot application, nothing fancy. There is some configuration in here. I am showing this because it gives you a hint of internal stuff you can configure. And this is a framework specific. So you can define different serializers with Axon framework. You can see that I'm using the Jackson serializer through the builder paradigm and constructing it. And I'm telling the framework that this is a message serializer by using the qualifier. This means that it's going to be used by all the messages we have. So for commands, for the responses of those commands, for events, for queries, and for the responses of those queries. Okay. This is what I have at the basis, the config and the plain main runnable. But I also have my core API package, as we've seen in step 1. And this core API package contains the different types of messages we have. So it contains the commands, the events, and the queries, and the query response. So let's go through them, because these actually dictate what we can do with our game rental app. We can apparently register a game, rent a game, and return a game. I have added commands to these class names to make it clear that they are commands. There's no necessity to do this. As long as they are current tense and clear to you that these are expressions of intent, it's fine. So you can see that these are register. So you want to register, you want to rent, you want to return. The flip side of these, once a decision has been made that operation can be performed, is the events. So a game registered, a game rented, and a game returned. So past tense. And I furthermore add event to make it a bit more clear. Then there are two queries, find game query and a full game catalog query. And there is a response object called the game. Let's also look into them because, this is our API, but they are just simple POJOs. You could almost call them DTOs, if you will. When you're making messages for the framework, so commands, events, or queries, I recommend to you that you make them immutable. If you're in JDK 17, I would use the records, actually, because that's a very clear and concise notation of just making an immutable object. Or if you're in Kotlin, for example, make a data object and make everything a vol so that it can't be adjusted. I'm very deliberately using the full-fledged example to make it clear, though. If we register a game, we got a couple of fields that are present when it comes to registering. We have an identifier of that game, a title, a release date. There's a description to the video game, whether it's a single player or a multiplayer game. I'm using some stuff for to make it serializable and deserializable by Jackson. And other than that, I've just got getters, an equals, a hash code, and a toString. The basics of a POJO. There's one specific framework thing in here, and that's the target aggregate identifier. So you might wonder, what's this for? Well, from our explanation in the slide deck, we had our command model and a query model. And I very deliberately focused mainly on the aggregate as a group of associated objects with consistency rules. The idea of an aggregate resides on both ends, but its heavyweight resides on the command side of our application. So when you're dispatching a command, you're likely going towards a specific model instance you want to adjust. You need to tell the framework how you want to route that message, to which instance you want to route it. And when it comes to registering games or renting games or returning games, we're going to route them based on a specific identifier of the video game, so that consistent routing, especially in a distributed environment, is maintained, giving you, a certain level of consistency and certainty that only one node is doing all that task for you. So this is what the target aggregate identifier is for. It tells the framework that this field, the game identifier string, is used to route this message. We'll thus also see that annotation when it comes to renting a game and to returning a game. The intestines of these commands are just a bit smaller. The events are, they are literally just POJOs. They are just a flip in this case. This might make you wonder, if I have a command, do I need to make the exact same POJO and name it an event? Well, in this domain, that is what happened. In a lot of domains, you might see that happening, but there is no necessity stating that you have one command and always one event. One command can have an outcome of 0 to n number of events. Maybe you decide not to do anything when you handle the command. That is fine. You don't publish anything because you weren't happy with doing so. Maybe you have a command that sets, I don't know, when it comes to, let's go back to the example of the car actually. When you turn the steering wheel, if that would be a command, turn steering wheel, I can imagine there's a steering wheel turned event, but also a wheel turned event. And you got 4 wheels. So you'd have an event for each of those wheels and the steering wheel that turns. So that would be a fair example of having one command with an outcome of several events. In our sample, it's just basic, to keep it a bit simple, but that's not a restriction. Let's look at the queries as well. We got a find game query. So this finds a specific game. This is with the response object of a game, having the title, release date, description, single player, multiplayer again. And the full game catalog query is really just a marker that we want to have the full game catalog, everything. So a find all. Okay, we got the core. And I've seen some things flow through. We all love games. Yes, yeah, I'm most definitely a gamer, Fjong. This is well, in all honesty, specifically why I'm doing this. You might see the cabinet over there. I got a ton of stuff. I really enjoy that. So a bit of a sneak peek into my personal life as well. I hope you don't mind. Right, let's actually start coding instead of talking about what we already have. The first thing I'm going to do is I'm going to add a new package. I'm going to call this the command package. So under the flow of IO Axonic demo, the game rental space, there is a notion of having my command model. I have deduced that calling this command is fair. No necessity for your end, but I want to show clearly that I'm doing CQRS, so command and query separation of those two. And I like to use this packaging format. In here, we're going to construct our command model. And well, we have commands to register a game, rent a game, and return a game. So that already sounds like they revolve around the game. So let's make a class called game. And we're going to make this package private. Because we want to further enforce that no other modules or packages are able to get that game. Remember, we want to use the messages. We don't want to have direct, well, import statements on these objects. Nobody should care about that. They shouldn't be able to access that at all. The way how they communicate with our game is through commands, because this is the command model. I'm adding this annotation from the framework. So I'm deliberately calling this an add aggregate annotated class right now. You can see from the import statements that this is a stereotype. Let's see if we can enlarge this a bit more. Might be a bit nicer. All right. You can see that this is a Spring stereotype, so it doesn't. It's a type of like add component or add service or add bean from Spring, but just Axon Framework's variant of this. What this tells the framework is that this class is capable of handling commands and that it needs to be, well, loaded through a repository, that it might do event sourcing things. All that goodness is all automatically configured for you by using that one annotation. All right, let's make some basics. We're going to add a private game constructor. This is required by Axon for event sourcing. If you recall, when I was explaining the event sourcing bit, we will first make an empty instance and then handle all those events on the instance again. So we need to be able to make that empty instance. So this is what we're going to use that constructor for, what the framework is going to use that constructor for. We're going to add another constructor for the register game command, because this is rightfully the initiation point of this command. Okay, so we got our first command handler. Well, almost, not just yet. Axon doesn't know that this POJO is intended as being a command, that you will be using this to put on the command bus and that it needs to invoke this method. We need to tell the framework that this constructor is capable of handling the register game command. The way to do that is by using the command handler annotation. By using the command handler annotation, we essentially tell the framework, specifically in a Spring environment, that it is capable of handling the register game command. This means that it will be registered with the command bus as being able to do so, taking all that routing logic in mind. Okay, so next step, we got our basic aggregate structure. Let's start thinking about decision-making logic, because that is what we're going to do, right? Well, I'm not going to do it right here in the constructor, because I just want my games to be constructed. I'm trusting that the registration process just works. I want to keep this a bit simple. So instead of deciding anything, we're just going to factualize it. We're going to publish an event stating that the game has been registered. So we're going to use that game registered event. But to publish the events, you might assume you want to use the event bus, but we're going to do it a bit differently. We're going to use a static method called lifecycle.apply. And this is where we're going to do the construction of our events. As you can see, I have as a live template. The fact we're using the aggregate lifecycle transitions back a bit to one of Mohammed's questions about what benefit the framework provides imposed to Kafka. So where in Kafka you need to decide where your events are going from a partitioning logic, to be able to do event sourcing in nice means, you will need to be mindful of that in Kafka. You need to be certain that all these events for specific aggregates go to, if I'm saying it correctly, to one partition, so that the ordering of those events is maintained. So you need to do this. From Axon's perspective, if you're inside the life cycle of an aggregate, which we are right now, we're inside the game, we can just apply an event. And the framework will know, oh, okay, this is apparently an event that belongs to this game object. So I need to put it into a separate bucket, and I need to find the numbering so that the order is maintained and that it is protected against. So that simplifies, well, your life compared to Kafka. And that's done through the static method. We're going to make that a static import because I like static imports. Our first command handler. Let's start thinking about loading this game, because this first command handler really constructs the game. There's no loading happening at all. The framework will check, okay, is there already an instance? Well, no, I need to create it up front. I'm going to make and publish the first event. But we want to do event sourcing. So when we have another command, for example, the rent game command, we need to do that on an existing instance. So we need to know the identifier to be able to load that instance. So we need to have a field in the game. We need to tell the framework what is the aggregate identifier, that external reference. So we need to collect this game identifier. So you might guess, well, I can set the state here, right? Well, no, you won't set state in command handlers, because command handlers aren't used to load your aggregate. If you recall, when it comes to event sourcing, we load an empty instance, we make an empty one, and then we invoke all those events again. So we need to have an event sourcing handler instead of a command handler. So let's add that. Let's copy this. I got a live template for this to get an empty event sourcing handler. You can see that, well, my preferred way of invoking this is called public void on. I think that's clear. And then it states the event it is reacting on. And you need to tell the framework that this is an event sourcing handler by using the event sourcing handler annotation. Sweet. We have written our first event sourcing handler, and we can start, well, sourcing the right fields to recreate our aggregate for subsequent commands. The more important one of this is, as I pointed out, the game identifier. So let's add this like so. And I'm deliberately going fast because this is kind of boring to see. I'm doing another annotation here. Because even if we have that as state in our aggregate, so we collect the state up here, right? So state here. And then we do command handlers here. And then event sourcing handlers down here. Just to break that apart a little bit. From that state, or the multiple fields of state you would need, this is the sole requirement the framework asks of you when it comes to a command model, when it comes to that aggregate. But you also need to tell it that this is the aggregate identifier. It is this annotated field that is used to match with the target aggregate identifier field so that that routing can happen. Okay, we got our basics. I saw a quest flowing through the bridge between Spring application context. So aggregate means a bridge. Yes, you can put it that way, Fionk. So this is a simplified means to configure. You can still configure it without this annotation because the framework is not requiring you to use Spring. And then you would need to invoke a so-called aggregate configurer. And you need to set it correctly yourself in the right positions, which is all doable and all written down in our documentation. Just using this annotation is sufficient. So it tells the framework essentially as a form of a bridge that you have intended this class as being an aggregate, and that it has command handlers in it, and that it has event sourcing handlers in it, and that it needs to be loaded on an event sourcing way. Right. Go for the following command handlers. We've got more. I also got a command handler live template. This simplifies my life, as I pointed out. We're going to do the rent game command because we want to be able to rent games at our game rental store. I think that's fair. Let's make it simple. Again, we do a game rented event. And at this stage, well, I need to fill two fields called game identifier and renter. We've got a game identifier state right now, because before we enter this command handler, we'll first load the aggregate based on its events. So the game registered event occurred and it's been handled. But the renter needs to come from here. All right. Well, nice, but we're still not doing any decision-making logic, right? It's kind of boring. Let's actually do some decision-making logic. And I got a couple of these up my sleeve, also already thought of. One of which I think is fair is that if you actually have a physical game rental shop, you can't rent out any number of video games. You have a fixed number of these. So your stock is limiting. So let's actually have a notion of a stock field. Just make that an if check. And in this case, we've decided to throw an exception if there is insufficient stock. This is regarded as a not okay from response perspective from command handling. If you just go from this, just applying an event, the framework would send back an okay, I've handled the command successfully. If you do it this, then the command response will contain that exception, telling the dispatcher, hey, something is wrong, I weren't able to do this. This merits more state, actually. We need to have that stock. So let's actually set that here. In the initial event sourcing handler, and I'm very deliberately calling this the initial event sourcing handler because this is the first event. So we have that stock, but we also need to change the stock when a game is rented or returned. So we need additional event sourcing handler. Let's do an event sourcing handler for the game rented event. We're going to do stock minus minus in this case. We don't have the game returned event yet, so we can't deal with that. Okay, let's do more state. I also think it is fair. We have the notion of a release date. I can imagine that as a game store, you might already get games that are, well, intended for a couple of weeks later, maybe a couple of months later. So you don't want to necessarily rent them out just yet because, well, you'll get fines from the distributor. You don't want that. So you want to adhere to that release date. So actually, let's capture that release date. Let's actually set that field up here. So yes, I'm going to make this a value so that it's part of our state location. And we're going to use that release date for another live template, unreleased. All right, so I'm checking what the time right now is, and if it's before the release date, we'll throw another type of exception. Fair. We got our basics. And I did see a question flowing through from Mohammed. How does Axon store events? How does aggregate convert the command to event? Bucket word passed. Are events written to a Couchbase database? Okay, so yeah. So you're asking, in essence, where the events are stored. Well, you've got several options here, Mohammed. So the framework out of the box provides roughly 5 implementations. One of these is in memory. Definitely not production ready, but if you want, you can use it. It's really there for testing purposes in most cases, or sometimes for some people it does make sense. There is a JPA based, so you can use any type of relational database that conforms with that. You can also go for JDBC if you want to have more fine-grained control over your queries and setting things up. There's also a Mongo event store if you like, and we got our own dedicated event store. This is what that Axonic Cloud was. Axonic Cloud is a cloud offering of an event store that we have constructed. You might wonder why have we done that as Axonic? Well, because relational databases or NoSQL databases aren't necessarily optimized to be an event store. What we need when it comes to events is store everything forever and never change anything. You just append data. This is in line with the conceptual notion of events. It is something that has happened. I can't change that. I can't in real life change the past either. I can't delete that because similarly, I can't change the past at all. So this is, from some perspectives, a limiting constraint. when it comes to the usage of event sourcing. Because when you're using event sourcing, we have that harsh requirement to have an event store to be able to load our command model from everything. And because there is that requirement, just using a relational database will get you a long way. Using a NoSQL solution will also get you a long way. But eventually the performance will degrade of those solutions because they're not intended to always grow and to always add stuff. There's an expectation that you might also want to do updates or deletes. And that's just not a necessity there. So we've constructed our own. We are not the only ones, mind you. So Axonic has a thing called Axon Server, which is an event store. You also got Event Store DB from eventstore.org, which Greg Young is at the basis of, or used to be at the basis of at least. That's also another event store out there. And there are other solutions on the go. In this case, I'm going to use Axonic or Axonic Cloud. So Axon Server in the cloud as the event store. And I don't have to configure anything for that because, well, the framework does a lot of the configuration for you. What I could do already, so let's move to the POM file. So I have Spring Data JPA. I have H2 on the class path. If I tell in the configuration that I'm not going to use something like Axon Server, then it will automatically store my events in H2, and you don't have to configure anything. The framework will automatically configure the JPA-based event storage engine so that it is called, and it will store those events for you. Will work fine for a long period of time. It's just a performance penalty eventually if you get too large. And I like to use Axonic Cloud for this because it gives me certain benefits like that performance, like other tools that I want to show you. So you specifically also ask for a couch-based variant. We don't provide one out of the box. So you'd have to build that if you want to. Because I'm in honesty don't know whether it's a JPA or JDBC connector to Couchbase. I don't think so, but I don't know. I do know that there are users of the framework that have constructed this themselves, and I believe those are open source as well. So you can look at that. It's just not within my sphere of influence when it comes to maintaining it. But if I'd be very honest, if you're going to do this, I'd recommend you give Axon Server a try. It is very flexible, very simple. You can use it for free in a lot of scenarios as well. So give that a go. Hopefully, if you actually need to do this in a business, maybe if you need hands with helping to explain the specifics, because the specifics of an event store aren't automatically clear. It's, in all honesty, a very new type of database. We can help with that. I gladly help with explaining that if you want to. I hope that explains your request, Mohammed. And if not, then you can drop more questions. I see another request from Fionk. For some reason, there's a thing in the way in my environment. Come on, let me read it. Does the event store have to be the same data store of the application? No, I would recommend not to, even Fionk. If you have an event, if you would be using Couchbase or Mongo or some JPA variant, I would store that in a different database than I would store all the other data in, because it has a different purpose. It is intended to be shared among different instances of your application, potentially intended to be streamable from an entirely different environment as well. So if you're going to use this, definitely use a dedicated storage solution for your events. I fully recommend that, because that's going to give you so much more flexibility if you're really going to use this in production, and you would need that. It just is, well, different. That infrastructure intent is very different. I hope that explains it. And sure thing, Mohammed. Glad to explain. That's I wouldn't be here if I wouldn't like to. Let's move back to our aggregates, because we're not done yet. We don't have everything. We still need one more command handler, which is the return game commands. I'm going to be very lazy, actually. I'm just going to put this over, call this returned. I don't want this to be an array. I We got a returner. Okay, so you can also add an event sourcing handler for this one to increment the stock because the game has been returned, so the stock is increased. I want to use another logic of validation. I think for whatever reason, the shop has decided that if I rent a game, I need to be the one to return it. Don't ask me why. I consider it a bit of a dick move, to be very honest, but it is what they've decided on. If I rent a game, I need to return it as well. So we need to collect the notion of who has rented and returned games. Otherwise, we cannot make that decision. So to that end, I'm going to add another field, which I'm going to call renters. I'm going to make this a hash set because one game will likely only be rented once by every person. Okay. And this will ask me to make a field set of strings. Another import statement. All right. So we got a new empty set right now. And let's actually fill it, because when we rent a game, we add the renter. When we return a game, we remove a renter. Or return, whatever. Okay. We got our basic aggregate. In all honesty, we already have a piece of the puzzle that we can start and run right now. So, oh, no, I'm forgetting one thing. No, faulty. I also need to use that validation, of course. Come on. So, we got that validation going. Okay. Now we have something we can start up already. So let's actually do that. And as you heard from my explanation just now, I'm going to do this through Spring Cloud or Spring Cloud, Exonic Cloud. So let me move to right window. Over here, I got cloud.exonic.io. So this is that Axon server tool I was talking about in the cloud. You can sign up here if you want to. I'm going to use my work email for that. You can also use GitHub if you like. And I got an empty, environment. I got a thing that's called a workspace. I've called that the Stevosphere because I'm Steve. And in this environment, I don't have anything. I don't have any clusters. I don't have any context, no applications. There are no statistics because nothing's happening yet. I need to construct a context to start with this, to run my application in. As we're in the game rental sphere, I think the name game rental is fair. I need to select the cluster I want to do this in. So we've got a couple of options here. We can do a shared cluster, a private cluster, or a custom one. These latter two, cost money. So let's go for a shared cluster because I don't want to pay anything right now. I don't need to. There are currently two locations you can select, somewhere in Europe, in Belgium, or somewhere in the US, in North Carolina, or South Carolina. I'm going for Belgium because that's closest by to me, because I'm in the Netherlands. We can use different approaches. So we can do a single node, we can do a multi-zone. These, however, also cost money, as you can see. So going that route will require you to add a credit card, if you will. For testing purposes, for playing around, I'd recommend you to do the developer solution. That's just simple enough. You do see that it has a data retention period of 14 days. So you will lose your data. But for playing around, that's obviously sufficient. So let's create a context. Okay. We got a game rental context. Now I need to make a binding for us to start our application to actually connect it automatically. So we move to the application bindings window, click the plus sign, and we call this also game rental. We need to select the context where this application is going to reside in. So this shows that you can have several applications under one context, belonging to the idea of a bounded context from the domain-driven design, actually. Right now it's just one-to-one. You see here I get the token or the key essentially to the cloud, but I have a simplified application configuration here that I can copy. So let's do this because this gives me all the properties I need to automatically start the application and to run it. So let's do just that. Let's hope the demo gods are nice enough to me. Most of the times they are, luckily. I don't know why I deserve it, but it is what it is. Okay, start it up. That's good. You also see some other specifics in here. We see that it has registered handlers. So a return game, a register game command, and a rent game command. So this shows another specific that I've slightly left out. If I move back here, close this window, and go to the dashboard, I now have our game rental application here with the context game rental. And we see it has a number of command handlers. What Axonic Cloud, or thus Axon Server, is not just an event store, but it is also a distributed command bus, a distributed event bus, and a distributed query bus. So it gives you that automatic communication, keeping in mind that commands need to be consistently routed, that queries need to have a form of load balancing and might go to several sources, and that events can be broadcast to everybody inside my context and need to be kept forever. So it is more than just an event store. It's also a distributed message bus. So this simplifies my life greatly, and you as a developer as well, because by doing so, I literally just have that one configuration and I get all that infrastructure goodness, instead of that I need to select Kafka for event streaming, some other tool for service discovery for command routing, and some REST endpoints to communicate commands from one end to another. You can still do that, but this is just a bit quicker. Okay, so let's go to, we got our game side. Let's fill in the query side, actually. So we've got another package, the query package. And in here, I'm going to construct a query model. I'm going to call this the game view. Well, this is very boring to build, so I got a live template for this. This is just an entity. So I've decided to store this in H2. So in that Spring Data solution, this game view has all the fields we have been seeing, so identifier, the title, release date, and all the other stuff. And it is, well, similarly just a POJO with two operations to change. That's to increment and to decrement stock, because we know we can adjust that. As we're in, JPA land, I'm going to call this game view repository. I'm going to make this package private, because we similarly don't want anybody to touch this, because they don't have to. And we keep it simple. We do it like so. All right. So we got the bone to store our query model. You see that this is already a lot different. The command model is all integrated by the framework, and you can just make the model and that's it. One of the benefits of doing that separation between command and query model is that for your query models, you can choose how you want to store, so that you can use the most optimized database you require for the task at hand. In a lot of scenarios, this might be a relational database. But what if you want to do text-based search? Then I would use Elasticsearch. What if you have really just a NoSQL requirement of storing, key value pairs? Then use something like Mongo if you want. Or use something like Neo4j for graph databases. That flexibility, because we have the events in the middle, our source of truth for everything, we can construct whatever type of query model we like in the future. But because there is so much out there, the framework doesn't do this out of the box for you, which I think is fair. So we need to make a means to actually fill or create our game view. We need to project those events into our projection. So I'm going to make a game catalog projector to that end. It's private, as we're now accustomed to. And I'm going to add a private final repository. So use a constructor. I need to change this into a Spring component, because we're in an Axon Spring environment. And with doing so, if we add message handlers to this class, the framework will automatically find them. I'm going to do another specific. I'm going to add a processing group. Catalog. This is not a necessity, but it will allow me to do additional configuration later. I'm going to linger on that. First, we need to be able to project our events into game view instances into our repository. So we need to have event handlers for this. And I'm very deliberately calling these event handlers, because they are not event sourcing handlers. Remember, event sourcing is the intent of reconstructing a command model based on the decisions it has made himself. So a command model publishes events, and it uses those events to recreate itself. The game catalog projector projects any instance of those events. So it just handles all the instances of those events. So here you use an event handler to clarify that. In the command model, in the game, you'd use a event sourcing handler just to reconstruct yourself. So I'm going to build an empty game view here. You can see I'm being lazy. Using another annotation as you've seen. Yeah, okay, straightforward. Let's add more. Game rented event. So we're going to do repository defined by ID for the game identifier. This is an optional view. I'm doing it so to make it additionally clear. It is present. If it is present, then we do optional view .get and then decrement stock. So we change the stock. If it's not there, we want to throw a not game not. Yeah, that's it. Okay. Sorry, I had to think about the templates that I've constructed up front, and we need to throw this. Of course. We throw an illegal argument exception if the game isn't found. Well, in all honesty, this shouldn't happen. You can't have a game rented event without it being registered, but maybe something funky happened to your database. Who knows? So it's always good to be a bit more protective and actually share that logic. I might have assumed that we want to have something similar for returns because we want to be able to adjust the stock. Instead of an increment, decrement, we do an increment in this case. All right. So we're handling our events. We're projecting the events into those fields that we're going to use for making that game view. But we also need to be able to query that game view. We need to be able to retrieve that instance and return it. So this is where those queries come in. You might recall we got a find game and a full game catalog query. We could make a separate component to contain those query handlers in, but those query handlers will use the game view repository because the game view repository is where we have our game view. We have our query model. So we can also add that in the projector. The projector, this component, is in charge of, well, making those views. So it also knows best how to answer the queries we have for those. So I've decided to add them here. I have another template and another annotation, the query handler. I'm going to use the game as the response type and define the game query as the query. What we're going to do here is return repository.find by ID, query.get game identifier. And now I need to do some mapping. And I need to do that because, well, there's our different objects. Or else throw game not found query, like so. Okay. You might wonder, Steven, why are you mapping that object? Why are you not just returning the game view from the repository directly? Well, because I want to be protective of the insides of my application. I very deliberately want to have an API on the boundary that is used for communication to the outside world. This is what the game object is for, that we have over here in our index, in our core API package. The way we store it, our game view, is in the query model. And well, we don't want to expose that. This is an entity with an identifier. I don't necessarily want to tell the world that I'm doing it like this, nor would you. No, that's just, well, good practice. You don't do that. So you do that mapping in place to make certain that, well, you keep your intent, your solution for yourself and expose it in a different format for everybody else. Go for the last query handler. This is going to be a list of string for the full game catalog query. And what we're going to do is return repository.findAll. And then we're going to do stream.map the game view its title, and then collectors to list. All right. So here you see that I've deduced that the full game catalog query doesn't necessarily return the entire game object. No, I've decided to return just the titles because this is intended to be an option to browse through the list of options there. Okay. See some Well, just some information from FolksDev. Completely fine. Okay, so I think we're done with our basic query end. So it is time to actually make an entry point into our system. So to make that UI component, in all honesty, this would already work if there are other applications able to send those commands and queries. But we don't have those right now. We could make that, but we don't have those. So let's use a REST endpoint, a REST controller, to simplify this for it so that we can actually test this. I'm going to make another package, the controller package. And what I'm going to add here is a game rental REST controller. I'm making that very clear. I also got the basics for this controller because that is a lot more easier, right? What you can see is that this is, well, I'm using Spring Webflux. So this is why that Webflux dependency was in class path. Request mapping / rental. I'm making this package private again because similarly, other packages or other components shouldn't care about the controller package. They don't need to access this. So just make it package private. Why am I creating this? Well, this is going to be our entry point to actually dispatching our commands and to dispatching our queries. So this is the component that's going to communicate with the command bus and the query bus to actually send those over the wire. So I could wire the command and the query bus here, but the framework has some convenience approaches to make communication a bit easier. We call those gateways. So there's a so-called command gateway simplifying that and a query gateway simplifying that. But on top of that, these allow us to change the APIs a little bit. So I'm going to use specific variants of these gateways, which are the reactor command gateway and the private reactor query gateway, because these two allow me to use mono and fluxes. And that's what I want to do, because I want to use the benefits of Webflux to get that nicer API. Got these. And now we actually, well, just need to make endpoints for these operations we have. So let's do that. Let's make an empty name for REST. We're going to use a post mapping, as you can see. Fire. All right, and that needs to come here. Needs to be a string of identifier 2. And this needs to be that game DTO we had down below. So again, another translation step. Not detour, DTO. And this is where we just, well, translate that DTO and that identifier directly into something else. So I'm using another translation step. This could be the entire command in here, if you will. That's an option you have. I've done this with applications as well. Just for sake of showcasing, I am using an additional layer because some people want to have a separate layer for the UI as well. So use the command gateway to send an operation. I'm going to build the register command and use that identifier in there. You see I'm being lazy. I'm using the send of the command gateway, and this returns a mono. You see it returns a mono of something, a mono of string. This is the only occasion where the framework will automatically return an actual string. And why? Well, because a registry game command constructs a new fresh aggregate, which has an identifier. And most definitely that identifier is needed for subsequent operations. So whenever the framework constructs a new entity for your command models, sending back an identifier is fine. In all other scenarios, it would just be a void. You don't get anything. A void of okay is success. If you actually get an exception, well, then you know command handling failed. Actually doing this wrong. Register. So we're just provoking the demo gods just a bit right now. Okay. Let's add the rest. Let's do the rent game command. We see we also have that identifier. We have another request parameter, the renter, which we add in the command. And here you see we do use that void because the rent game command, well, there is no return from that method. If we go here, it's just, well, if it exits here, there is no value. It is void. But those exceptions are still carried for you by just throwing them, actually, which we'll also see in a couple. Or we add the return. You might have guessed it, quite similar. Let's go for the queries as well. Let's do the empty find game. Here we're going to use the query gateway. And this actually has a number of operations, as you can see. We can do a query, which is a point-to-point query to one source. We can do subscription queries, that we subscribe to be kept up to date. We also do a thing called a scatter-gather. There's even another type of streaming query. All types of options here when it comes to querying, because you want to do queries in different formats. So a bit more freedom on this API. But I'm going for the simple querying right now, because for this one, I just want to find a game for this identifier with the game clause in hand. Like so. Right. Report. So I have more full game. I need to refresh my mind a little bit. I called them differently. Yeah, here we got the watch. Okay. Let's also do a watch. Actually use that flux logic. I think that's fair. We're going to do a query gateway, but not just a regular query. No, we want to be kept up to date. We want to get those updates streaming through because we are returning a flux, right? So we want to subscribe ourselves. Subscription query many returns a flux, as we can see. So let's start using this one. So whenever somebody wants to watch the game catalog, so they want to do a full game catalog query, we want to return the string. Okay. I also want this in a different format, actually, but I, honestly, forgot what that operation was. This is what you get when you do demos late in the evening. All right, so I think I got all there is to it. So we can move back to starting up our application anew, so we have more stuff flowing through. 1 hour, 36 minutes. Ooh, it's a long session. I hope everybody's still sharp and present. If not, feel free to approach me or anybody that's working with Axonic at a later stage if you want to work with this stuff. We see some other things happening. Application is started. We see another thing here, the tracking event processor. Ooh, this reminds me of something I want to do. You can see here that this tracking event processor has game catalog 0 attached to it. What do you recall? You might recall game catalog from our projector, from this exact name here. So you can see that the framework uses that processing group annotation to give a name to our components that are handling or processing events, tracking, apparently. Well, this allows us configuration options, actually, which I want to use, because that's nice. I'm going to use Axon event handling.processors. This is where the name comes in. And then we have a number of options like thread count, the mode, and batch size. And, well, I actually want to use a different mode. I want to use the pooled mode. And I want to use more threads. Let's use 6. Okay. It's nice. And I think that's it. Yeah. I'm going to clear out the database just to be certain, because you never know. Maybe something is in the way. We're demoing anyhow, so we should be able to. All right. Okay, so we start application. You see it's a bit different right now. You see, don't have a tracking event process. We got a pooled streaming for right now. No, that's that mode. I can tell you, it's the pooled mode, and we got a coordinator with 16 segments now. Okay, fair enough. So, no, working a little bit different. Let's close that one. Let's see how this has changed the dashboard. Actually, well, didn't update it yet. If you move to it again, oh, that's interesting. You're not showing up, are you? Serious? This is what you get from doing demos, right? These are just query handlers. That's interesting. Huh. Let's shut it down just to be certain. I also don't see the query handlers being registered. Ooh. Actually, parse it. Maybe Spring Boot DevTools is being nasty. So I do like using Spring Boot DevTools, but sometimes it just gets in the way. It's not listening to what I wanted to do. Okay. So we do have to, here now we see the query handlers as well, the full game catalog query. So I'm very happy I checked that before actually running stuff, because who knows what might have happened. All right, so now we also got our query handlers, as I expected. Okay, and we got our event process, our event handler with the threads. You see that all this is running here. We got some additional buttons here as well. We can actually pause it if we will. Oh, error occurred, unexpected end of definition. That's lovely. This is what you get with doing demos, right? Okay, so it did start and stop apparently. It was just not showing the message. Okay, so this shows another benefit of doing this through Exonic Cloud or through Axon Server. We got capabilities to stop event processing with that plus and minus. We can also decrease the amount of threads that are actually going to do work. Here you see that we're now on 15. We can now move this to 14. We can use this to 13. In all honesty, I don't know why it's throwing exceptions at me, but yeah. So this might be off because you saw that thread number on 6. Well, this reflects the amount of segments that are actively being worked on concurrently. So this should actually be, well, concurrently accessing components. So need to change that. This gives us freedom to go to this page, to the game rental page, which shows nothing, which is very apparent because we haven't published anything yet. So let's start publishing some events. Now, what I have prepared similarly in this application, this is why I like IntelliJ as well, so you can have .http files so that you can automatically do a bunch of operations. So here I got a register games section where I can register a bunch of games like Doom or like Command and Conquer, Tiberian Sun, or Halo or Final Fantasy. I've added these for a reason, obviously. So let's run all of them. Let's see if they work. Well, I got a 200. That's good. So this seems to have done the shebang. I can move back, refresh this. We should see a number of games. So this is now our event store. Murphy's Law. Yes, Lee, definitely Murphy's Law. Stuff like that happens, right? We see a couple of things here on this page. We see tokens, we see event identifiers, aggregate sequence number, the type, the payload, the revision. This is all data that if you're using some other type of implementation of the event store, you will need to set up. The framework will automatically allow you to do JPA, JDBC, and the Mongo variant, doing all this for you. But if you want to use a third option somewhere out there, like Couchbase, well, you need to ensure that all those fields are present. So let's move the event identifier. This is just a unique field you'd always have. We're also not going to do revisions of our messages, so we can remove the revision as well. The timestamp, well, that comes apparent from events. So let's clear that out as well. See that this view is also kind of helpful. So here, the token on the left is the overall ordering over the entire event store. So game 1, 2, 3, 4, this event was the first event in the store. Now, any new events I would add would just increment this number. It is this number that the framework uses to deduce where you are in streaming your events. So this number is also stored somewhere in the framework, in your database, so that it knows when you start and stop your applications that they don't automatically start from scratch again. This aggregate sequence number is used from the event sourcing perspective. So when you're loading each of these games, you want to retrieve all the events belonging to a specific aggregate identifier in the ordering of the aggregate sequence number, so that you handle them in the right order. That is what this is for and what the aggregate identifier is for. We only have one aggregate type, that's the game. The payload type is the fully qualified class name. I can click this actually to get more detail. You can see I've got the fully qualified class name here, and the payload data is in JSON. Here, apparently, I've opened the new The Legend of Zelda, Breath of the Wild 2. It actually has a new name now. I should have changed my my sample here. What's the point I want to make? Yeah, this comes back to that I was configuring my message serializer as being a Jackson serializer. If you might recall, application config has this in here. And this specific dictates that I'm now using Jackson here. Okay, all right. I think I've shown some of this goodness. I think it's time to show the other operations that they're working as well, because we've got a bunch in there. So this is actually where we have, yeah, this one. This is what I wanted to add, which I forgot to add, the full catalog. I knew I was forgetting something. Let's just find one game. Let's find Elden Ring. This is actually a game I'm still playing right now, even though it's already been out for quite some time. No, this seems to work. I got that game. Let's close that one. We don't need it. Let's find a game that doesn't exist. We know that this should throw an exception, because that's what the game catalog projector does. If there is no game to be found, I should get this. So let's actually validate that. If I do this, yeah, I get an exception. Game with ID 000 could not be found. Nice. Okay, let's go for more operations. Let's assume that my boss, Allard, will rent a game. 1, 2, 3, 4. That was successful. This should also have generated an event, actually. Let's move back. Actually do this. So, yeah, we see another event for aggregate 1, 2, 3, 4. You see also that it has an incremental number for the aggregate sequence number, because it is the following in the flow. Okay, nice. Let's assume that I'm going to rent out game 5, 6, 7, 8. And Lucas is going to rent out 9012. All right, well, renting apparently works for several games. Let's try out that validation we have. Let's assume that Stefan E wants to rent out 5, 6, 7, 8 that I have already rented as well. So he tries that, but no, we don't have sufficient items for this, Sir Steven. My apologies, you can't use this one. Bummer. Let's try something else. He wants to rent out 9100, but that's not been released yet. So sorry, sir, you can't rent this either. Go for something else. Okay, so that works. Let's see how it works with returning. Let's assume that I return my game. If I do this, okay, success. This actually means that Stephanie should be able to rent it. Also a success. Nice. Similarly, this should be visible on our event store page. So we can do something like this. Oh, it's still in live mode, yeah. Aggregate identifier. Is 5, 6, 7, 8. I believe this should work. Right. So here now we see the flow of game 5, 6, 7, 8. Just that one. So we can do that query language in there if you like. Okay. Let's see if I try to return the game for Allard, because I'm a good colleague. But nope, we're not able to do that. The game should not be returned by anybody else. Okay, then we got one last thing to validate and test, and that is that flux. We want to be able to watch the catalog and get automatic updates. So for that end, I'm going to do a watch here, which I have up here. I'm going to run this. I'm going to make this a separate window if it wants to. It doesn't want to. That's a shame. So let's watch again. That simplifies it. No, doesn't allow me to. Bastard. Okay, so we're now watching. This is still a live query. So we got all the games: Doom, Halo, Super Mario All-Stars, Cyberpunk, God of War, Ragnarok. Another one. And if we do this, the new game has been added, and it's automatically appended here. Oh, it's not. What happened? Yeah, demo gods. My apologies. So this actually very clearly shows that automatically flowing all those updates is not something the framework knows. The framework isn't in charge of your game views. You are. You make that projector to automatically flow all those messages through. So the way how you should have done this, which I neglected to do, is to tell when a new update is there. To that end, you can introduce a thing called the query update emitter to emit updates. So let's do that. We're going to emit updates. And the moment we're going to emit updates is when a new game enters the catalog. So that's on a game registered event. To that end, we want to use the title, because that's what we want to share. We're going to use update emitter to emit an update. Well, on this emitter, we got a number of parameters: a class, a predicate, and an update. And that's actually the format we're going to use. We want to react on a specific query type, which is the full game catalog query, like so. Then we need to provide a predicate of the query we get. Well, there's nothing to validate on in the query, so we'll just return true. And we actually want to return the update, which is the title. So we return the title. Okay, this is what you get from doing live demos late in the evening. So I actually want to show this. I think that's fair. So Okay. Waiting a little bit. Okay, it's running. This requires me to add or set on that watch again. So let's do that watch. Now we can actually do this. Okay, we keep it there, keep it open. And we're gonna add another game. I actually recall something right now. Most awesome game ever. Not true, but Stanley. We played this. This is a very nice game, actually. We need to give it another number. So I assume that 1111 isn't in use. So if I now click post on this, I should get that watch updated automatically. And that worked. Nice. I got that flux going. All right. This is what I had demo-wise. So we can go to our question section again. And I did see another question from Mohammed. How does Axon solve the lag problems? For example, what can be done against the lag that may occur in situations where we have produced too many events that we are slow in consuming? Yes, Mohammed, this is a very, very good question, I think. So eventual consistency is the term you would use here when what we're doing when we're doing CQRS. So let's get that image in place. So what we're doing with this approach is we're making two units of our application, two separate groups, two separate thread groups, potentially two separate microservices as well. The left is making decisions and publishing events, and the query model will on its own accord handle those events. So you want to be able to optimize the consumption of those events. And yes, you have capabilities to do so. This is in part why I switched to a pooled streaming solution. So one of the things I did earlier in the properties file is I was playing with the properties of the so-called game catalog. This is also why I gave the game catalog projector a dedicated name, a dedicated processing group, because this makes it easier for me to reason about this component when it is slow. So one of the things that the pooled streaming event processor does compared to the default, which is the tracking event processor, is that it automatically constructs 16 so-called segments. You saw that a little bit in the dashboard as well. And if we move over here, if we open this up, we see 13 threads, but up here, they're called segments in the top corner. What this means is you could roughly compare this with Kafka's idea of partitioning. We just do it on the event consumption end instead of the event publishing end, where in Kafka you need to deduce that up front so that those are put in those buckets. From the framework's perspective, you can deduce any number of segments you want to use. So I can increase here the number of segments. Well, for some reason, it's giving me exceptions. I don't know why, but this allows me to break up the stream, the event stream, into more partitions so that more threads can concurrently handle those events flowing through so that you can, do that in a more efficient manner. The fact I was using the pooled streaming variant is because it has better performance characteristics in heavy concurrency environments compared to the tracking option. So if you're going to use this, I would recommend using the pooled streaming one. It will by default use 16 segments. It would still by default internally use one thread. This is what that other number was in the settings. I could change the thread count. This is the thread count on this instance of the application. If I run multiple instances of the application, I would get plural. Let's actually do that. Let's do a configuration edition. So we copy this one. I haven't seen this in quite some time. I thought there should have been more information on this page. Manage. No, run on. Come on, what's this? I have more of these. I actually had these prepared. This is literally the demo gods being an ass. Here, the distributed variants. Can I edit this? Jump to source. It's not even doing that. Open running configuration in new tab. No, it's not doing that. Okay. I didn't even copy it. Modify options. Okay, I'm not going to do this because it's going to take too much time right now. My apologies, Mohammed. Because this is outside the question you're actually asking. So the framework allows you means to play with those event processors. The event processors most definitely have the most configuration options out there. There are a bunch you can use through the properties file up here. So there are several, as you might have quickly seen. Another one you have is the batch size, for example. So by default, Axon uses a batch size of one event, meaning that every event it handles is a new transaction. This may work, but it may mean that if your application pumps out millions and millions of events, that batch size is not ideal, that you want to increase the batch size to perhaps 100 or to 500, that you do handle 100 or 500 events in one transaction. This also means because Axon deals with the transaction logic of your query models as well, because you might have seen that what I've been doing in the projector is nothing with transactional annotations whatsoever. Axon is doing that for you. So if you increase that batch size to 100, that means it'll do 100 updates and close the transaction afterwards, helping you further in that perspective. And you can thus also change that segment size on the fly, which I was showing here with those plus and minus operations. You have this load balance option on the right, which I wanted to show just now by introducing a second instance. This allows us to share the load evenly over several instances of that event processor. So that's the last step you could do. You could scale out your application instances. And this, well, in all honesty, turns back to the idea we had at the start, right? So I'm going to move back an entire bit. So that need that eventually you need to go for several instances, the moment you figure out that your event processors are lacking, that's likely something you already feel coming when you're going into production. You see through metrics that you would add, okay, this application just needs to have more resources. So let's assume that this purple bucket is our game catalog projector instance, and just that instance, and we'll just run it, in a different format several times, and then share the load over all those instances with that processor in place. Okay, I think that's it. Steven, are you planning to share this code on your GitHub account? This is already there, Leafman, so that's very good. So let me go here. So if I go to, because I have been doing it live just now, but I always have a backup for, I use the same sample project more often. So as a backup, there are several steps in this. So here I have the main branch, but you can see there's a step 1, 2, 3, up to 9 actually. The main one has the fulfilled implementation, showing a step to do the core API, the step of the command, the step of adding Axon Cloud, the query model. And this is honestly where I ended with the REST controller. But there are more steps to add exception handling logic, to use separate profiles so that you can actually break up your application, if you will. And I'm going to use RSocket as a different means instead of REST, if you will. So you can just try that out. So most certainly, please play with this. If you find any issues, please file a bug. That's completely fine. I'll be very responsive on this. It gives you a full explanation of how to use this, how to run this. There are also test cases in there for the separate steps. And I got a little bit down below if you want to start your own project. Because for that, we actually got started at Exonic.io. You see that already at Cloud Console open. We have our own Spring Boot starter, or start.spring.io essentially. So this is a flavor of that with Axon logic to it, where you can see you have dependencies and you can add several more. This is what I initially used to construct this project too. And another one, I already saw it coming. Yeah, exactly, FolksDev. Very much, developer.exonic.io. This is Axon's developer portal. So this is intended to be the starting point for when you make your application. So it has a bit on the concepts, about the products we have as well. So we got several things like I've been talking about. There's also a learn bit, and more interesting maybe, which I definitely recommend if you want to see more of me and my colleague, is that we have an academy page. This has courses. Some of them are free, some of them are paid, but the free ones definitely go through the basics in more detail than I've done today, and also the basics of the framework in more detail than I've done today. So this is also a very nice, learning experience, I'd say. All right. Thank you. I'm very happy that the demo was helpful for your leave. One more app for another part. Thanks for your demo and answering. I very appreciate for that live stream. Glad. I'm very happy to do this. What are the most frequent use cases of CQRS? So that's a good one, Tubanur. What I personally think is that just doing CQRS from the API perspective, so having commands and queries as the way to define how you enter your application is reasonable in any account. It embraces the idea of being able to do asynchronous stuff and being more reactive. And that is a flow that a lot of people want to go through anyhow. So purely on an API level, I wouldn't limit myself to any type of application. But I've been doing CQRS combined with DDD and event sourcing. So a more fleshed out solution with an actual command model and an actual query model. Whether it's always reasonable to do that, that's doubtful. What I see most often, that if the application is straightforward, and with that I mean you can come by with literally just having a create, an update, and a delete, and you don't have very specific business requirements, then I don't think this is the tool for you. I have seen people do it. I know that there are clients of ours doing this, and you're perfectly free to do so. But it requires a certain level of knowledge on doing these paradigms. If you have never done this before, and you would do that in a production environment, you might be overcomplicating it. And it might also be tougher to find developers that are familiar with that mode of programming. However, if you're in an environment where your business logic is very intricate, then I do think there is benefit in doing this, doing CQRS, but also definitely combining that with DDD and event sourcing. So the bigger users in our space that we are in direct contact with are the larger online or offline stores. A lot of banks, because banks, the majority of their domains, specific solutions, right, for mortgages or for credit cards or for large-scale sales when it comes to business trades. We have several banks doing that with our stuff, because they have that requirement of an audit log, for example, or to clearly define their APIs in their entire ecosphere of units. There, that most definitely helps. I also see it a lot with governmental agencies, because specifically when it comes to paying out the taxes or dealing with the employment registries of systems that needs to be managed, maintained forever. Rules and regulations might change within a company or within a country, and that needs to be complied with too. So to make the answer very basic, it depends. But what I would use as a rule of thumb, if your domain becomes complex, if the business logic demands certain specific solutions, I think there is merit in trying this out. Okay. That's actually the last question in the list, but there might perhaps be more. Granted, we have already been here for 2 hours, so maybe somebody wants to do something else. I believe that in Turkey it's now 8 o'clock. I don't know whether that's dinner time or not for you, but if there are any questions, please drop them. Oh, I see I have another chat message up here. Sorry, Sagri. Bit of a late reply there. But yeah, if that's it, slide here. Well, yeah, I just showed academy.exonic.io. If you want to see the framework, you can go to github.axon framework if you want to. That has not just the framework repository that I've been using, but also those extensions if you're curious. I've been using cloud.exonic.io to kickstart it, and there's start.exonic.io to start that application. And all these are combined on developer.exonic.io that FolksDev has shared with all of you. And well, if that's it, if there are no more questions, then I'd like to thank everybody for being here. I really enjoyed this. This was fun. Who knows? Maybe I can do this in the future again, if there is need for it, of course.
Yeah, of course we will need more. We will never say that is enough, you know. I directly jump in your session, and it was really, really great demonstration. And I would like to say, I mean, we are really grateful for your demonstration. Let's see is there any new comments or questions. Yeah, here it is. This was the best explanation with you on Interact. Yes, I'm
much appreciated.
Yeah.
That's a good one, actually.
Yeah.
What should someone pay attention to who wants to redesign a project with crowded business logic with CQRS? Oh, yeah. That's what I would do, Tubanar. Again, hoping I'm pronouncing your name or your tag correctly there. Try to find a piece of the application that you can break out of the whole sphere. So where you see this most often is that there is some form of a monolith in place. So doing a lot of logic, right? And pick a unit that is relatively straightforward, where the business logic is not extremely complicated, so you can play around. And then you would slowly move over the APIs to that component. So you would likely build it internally first with making a command model and perhaps making a query model, having the right commands and events and queries. And you make a form of a gateway component because likely that application does something with REST, and you would just delegate the old REST operations to the new one. This pattern can be described as the strangler pattern. So you would slowly break up the application into new units. I think that's most feasible. I have people seen doing a massive rewrite in one go, which is an option, but that might be a bit tough. So what should you pay attention for? Is that really the good answer? That's more an approach that I'm now explaining. I would pay attention to the well design of your messages.
Yeah. I wanted to say the same thing as a user of the Axon framework. The most important thing, you have to spend at least 80% of your time for your event flow design. Otherwise your application would be really a mess. When we started our project with Axon framework, we maybe didn't take too much time on the event storming, we say. I mean, the brainstorming of the whole event flow. And then our application started to become more and more messy with each event. So with the CQRS route, it is really important to have a clear event flow and design.
Yes, most exact. I'm trying to find, because I know you have a couple of blog posts on event storming and event modeling. I'm going to try to find if I can see those, because I think no, this is definitely not it. Blogs, I guess. Nope. Lovely. I should know all this by heart, right? No, but doing indeed, like you put it, definitely put emphasis on well design of the API, because this is, well, in part why that demo just starts with an API being there, because doing that design of the API would be in another demo on its own entirely, because you need to put a lot of emphasis on this, a lot of discussions with yourself, with your other team members, with other business units inside, because everybody has different ideas of what the application does. It's in essence getting an idea, a well-grained idea of what the domain is intended to do and how communication in that domain happens. And well, without that, you can still make something that works, obviously. But like you pointed out, there might be a point in time where you think, okay, this isn't what I wanted to do. It needs to be different. So I actually found the blog, so that's good. So from model to code, as you can see, this is a 2-part series actually. So there's a there's a 3-part series actually. These are 3 parts. And modeling and Axon framework. So I would definitely recommend this one. So let me. Can I share that in the comment section?
You can share in private chat, and I'm gonna share.
Yeah, I'll share it with you. Yeah. So definitely give that a read. That has a, well, it explains how you can do this. Event modeling is not something that we have thought of, nor is event storming. Those come from different people within the environment that put a lot of effort into this. So.
We have one more question from Tubaner.
Yeah. Okay. What are the worst cases of implanting? Worst cases of implanting. Do you? How should I see this? What are the worst case scenarios? Something like that.
Yeah, for worst case scenario, I guess.
Yeah. I in honesty think having your events not well designed. The downside of doing this event sourcing is that requirement of your event store having all that stuff till the end of time. You don't delete anything, you don't update anything, you don't change anything. So if those events aren't in the format you're really going to use them, well, that's going to be problematic. The framework gives you means to work around this. You can solve solutions you're not happy with. You might recall in the Axonic dashboard, I had that payload revision column for the events. Well, your events have revision numbers, and there is a means to change them from older to newer versions. The framework provides tooling for this, but going through that exercise is likely painful for a lot of people at first. It is very doable. I've done it a ton of times, also at end products, but well, we can conjure up a more pleasant API, and I very much want to have something more pleasant in there for the framework. It's just not there yet. So the worst scenario you can be in is a badly designed, domain model of your events. That's what I would dislike most. What's your take on this? Maybe you have 2 cents too, Shaggy.
No, I would like to ask the relevant question, the worst case. I'm just wondering that, currently we are using Axon server as an event store. And just wondering that, Axon server is our source of truth, basically. If, let's say, Axon server went down and we cannot reach, but the application still continue to work in, what would be happened? How we gonna make our event safety in that scenario?
Okay, that's a fair point. That would also be a problematic if your event store is unreachable. So how we try to deal with this through, especially in the cloud scenario, that's really under the hoods. So if on our end one of those Axon server nodes stops, it'll spin up a new one, and you'll be guarded against that, and your data will be backed up for you. If you're running Axon server yourself, like you're doing in your environment, you're likely not running a single instance. You're running them in a clustered environment. So the event store is by nature distributed and clustered, so that we are fault tolerant against at least losing one of those instances. This means that your application, so the framework one that I'm running, would connect to at least one of those. But if one of those dies out there, I can still move to one of the other instances. It would not be happy though. In a 3-node Axon server environment, that is the minimum, you are fault tolerant against losing one of them. Because if there are 2 down, then they cannot form a consensus of what has really happened. So we're using a distributed consensus algorithm in there, which we have implemented. It's based on the Raft consensus algorithm. Very interesting stuff, very theoretical. If you want to read it, we have some blogs on that as well. But so yeah, we protect you against that by having you run it at least 3 times. It doesn't mean you can't use Axon server with 1 node. That works. That is regarded as the standard edition, and that is completely free. But it means you're not fault tolerant against losing an Axon server node. So the enterprise variant would cost some money. Yeah.
That was my worst case scenario, by the way, in my mind.
Yeah.
To lose the whole Axon server cluster. What we gonna do? And always you should have fault tolerant system cluster, whatever you are using.
Fully agree with you.
Right. Thank you, Steven, FolksDev, and Turkish Show community. Yes.
Glad.
And one more question from Mohammed.
Yes, Mohammed. Yes. So this is when we run a 3-node Axon server cluster, they are in communication with one another. And when your Axon framework application publishes an event, that goes to one of those nodes, and that node will enter that distributed consensus algorithm logic, try to replicate that event to at least the majority of instances. And as soon as it's at the majority of instances, that means that the event publishing transaction was successful. So that it's at least at 2 nodes. So it does that for you. You don't have to do that at all.
Yeah. Perfect. And
Great.
I'm really appreciate again, and I'm really grateful to be with you to hear. I'm gonna do some YouTuber announcement. Please don't forget to subscribe our channel and don't forget to support us with your comments and likes. It would be really grateful for us. And again, thanks so much, Steven. And hopefully we will see each other again in another broadcast show. That's
let's do
it.
that.
And
I think that's a nice idea.
so much. Yeah. All right. That was it from us for tonight. And we will see each other tomorrow again. We will have another broadcast with really great subject, which is computer vision and machine learning. So from one of the Google expert developers, İrem Kömürcü, she gonna demonstrate computer vision and machine learning. And for today, thank you again for joining, and see you tomorrow.